Okay, I hope I'm audible to all the students who are attending this lecture. We start with a new topic in statistical methods for economics. This is called hypothesis testing. It's a very important topic in statistics, or a better way to put it is inferential statistics. This is a very important topic in inferential statistics. Okay. So I will be referring to the book J.L. Devore for this topic as well. Okay. After having discussed about how to estimate the population parameter using point estimation and using interval estimation procedures, as you can see in the previous lectures, okay, now in this lecture we are interested in setting up a hypothesis. So first of all, you should know what is meant by a statistical hypothesis. So we can write a statistical hypothesis. A statistical hypothesis is a claim or an assertion. It is a claim or an assertion either about the value of a single parameter, or about the values of several parameters. All of these are population parameters, or about the form of an entire probability distribution. So students, what we need to understand here, when we make a hypothesis, when we make a statistical hypothesis, it is a claim regarding the value of a single population parameter or about value of several population parameters, or the claim can even be about what is the underlying probability distribution. So when you are hypothesizing something, you are making a claim that, okay, let the population mean be this. It's a claim you are making. And then we'll be using the test procedure to see whether the hypothesis we have made in the beginning, should it be accepted? Is it true or not? Okay, so let's talk about what are the components of hypothesis testing. Let's talk about the components of hypothesis testing. Okay, so hypothesis testing has the following components. Within this, the first component is called the null hypothesis. Again, guys, null hypothesis, which we denote by H naught. Null hypothesis, which we denote by H naught, is the claim that is initially assumed to be true. It is the claim which is initially assumed to be true. Okay, so when we make the null hypothesis, initially we are assuming that suppose it is true. Then the second component we have called the alternative hypothesis. Alternative hypothesis. Now guys, alternative hypothesis is denoted by HA, and you can think of alternative hypothesis as the negation of null hypothesis. Now students should know the concept of negation from symbolic logic. We have done this in the mathematical methods for economics lectures. Basically, alternative hypothesis will consist of a statement which is contradictory to null hypothesis. It's like a negation of the statement under null hypothesis. So we can put it like this. Alternative hypothesis is the assertion that is contradictory to the null hypothesis H0. Okay, so we can say that the null hypothesis, so I'm putting up a point here, the null hypothesis, which is H0, will be rejected. The null hypothesis H0 will be rejected in the favor of the alternative hypothesis HA only if we take the sample evidence and the sample evidence suggests that our null hypothesis is false. So students, I hope you are understanding what are we trying to reach at. Basically, we are making a claim called the null hypothesis about either the value of a single population parameter or about several parameters or about an underlying probability distribution. And we are assuming our null hypothesis to be true. Now, what do? We will collect a sample. From the sample, we will adopt a test procedure. Now, in 2 minutes, you will understand what is a test procedure. So basically, we'll be analyzing the sample and then we'll be concluding whether the null hypothesis we made in the beginning is true or false. If it is true, then we will accept the null hypothesis. If it is false, then we will reject the null hypothesis and we will accept the alternate hypothesis. Alternate hypothesis is the negation of null hypothesis, or it contradicts the null hypothesis. Okay, so I hope students have understood what are we trying to do. What actually we'll be doing will be coming up in a few minutes. But right now you should be convinced regarding what is hypothesis, what is a statistical hypothesis, what are the basic components of hypothesis testing, okay, which are null and alternative. We make the null hypothesis in the beginning, we assume it to be true, we work out the sample, we analyze it using the test procedures, which we'll be discussing in a few minutes. That will help us in concluding whether the null hypothesis is true or false. If it is true, we'll be accepting it. And if it is false, then automatically we are accepting the alternate hypothesis. We are rejecting the null hypothesis. Okay. So let's understand what is meant by a test of hypothesis. Okay. So I can write a test of hypothesis. A test of hypothesis is a method for using the sample data. It is a method for using the sample data to decide whether the null hypothesis should be accepted or rejected. So when we talk about a test of hypothesis, it is a method for using the sample data to decide whether we should accept or reject the null hypothesis. Now, I was discussing a few minutes back about the test procedure. What is a test procedure? So now all of you will come to know. A test procedure is a rule based on the sample data. It is a rule based on the sample data for deciding whether to reject or accept the null hypothesis H0. So when we talk about test procedure, it will be a rule. Now in a few minutes, you will also see the rules, okay? But a test procedure is a rule which is based on the data collected from the sample, which will be used to decide whether we should accept or we should reject the null hypothesis. What should we do? So everything will be based on this rule. Okay, so now test procedure consists of the following. So a test procedure consists of a test statistic. Now guys, what is a test statistic? So a test statistic is a function of the sample data. It is a function of the sample data on which the decision to reject H0 or do not reject. Do not reject means accept. Do not reject H0 is to be based. So when we talk about a test statistic will be a function of the sample values. And that test statistic will be used to make the decision regarding whether you should reject your null hypothesis or you should not reject your null hypothesis. Within this test procedure, we have something called the rejection region. Very important. So rejection region is the set of all the test statistic values. It is the set of all the test statistic values for which the null hypothesis will be rejected. Okay, so rejection region will consist of all those values of the test statistic for which your null hypothesis will be rejected. So I can write a point here to highlight it further. The null hypothesis H0 will be rejected. You will be rejecting the null hypothesis if and only if the observed test statistic value, falls in the rejection region. So I hope all students have understood the terminologies which you can see on your screens right now. You should understand what is a test of hypothesis. It is a method which will be using the sample data to decide whether the null hypothesis which you have made in the beginning should be accepted or rejected. To do the hypothesis testing, we adopt something called the test procedure. It is a rule which is based again on the sample data to decide whether you should accept or reject your null hypothesis. Within the test procedure, you further have two components. One is called a test statistic, which is a function of the sample data on which the decision to either reject or do not reject the null hypothesis is made. And then we talk about the rejection region. So rejection region will include the set of all values of test statistics for which you will be rejecting your null hypothesis. So basically, guys, you will be rejecting your null hypothesis if the test statistic value falls in the rejection region. So now the question arises, how will you find out your rejection region, your acceptance region? So now let's discuss about how to find rejection and acceptance region. Now to understand that, guys, we are doing a very important topic called errors in hypothesis testing, because this will explain you how we can determine our rejection region. So what are the errors which are made in hypothesis testing? So the first type of error we have in hypothesis testing is called as the type 1 error. Okay, so type 1 error consists of rejecting the null hypothesis H naught when it should be accepted. That means, guys, when you are rejecting the null hypothesis when ideally it should be accepted, it is true. You are making an error, right? What is the error you are making? You are rejecting the null hypothesis when ideally it should be accepted. This is called the type 1 error. Okay, so when it should be accepted means that is when H naught is true. You are rejecting the null hypothesis when it's true. And then we have the type 2 error. Now type 2 error under hypothesis testing is completely opposite of type 1 error. So type 2 error consists of not rejecting. It consists of not rejecting the null hypothesis H naught when H naught is false. That means, guys, indirectly, what are we pointing out at? Type 2 error means that you are accepting the null hypothesis when it should be rejected. So I can say this means that we are accepting the null hypothesis when it should be rejected. And this means type 1 error. This means that we are rejecting the null hypothesis when it should be accepted. I hope all students have understood the statement. Okay, the statement is that in case of type 1 error, you are rejecting the null hypothesis when it should be accepted. In type 2 error, you are accepting the null hypothesis when it should not be accepted, when it should be ideally rejected. Okay, so now I am showing you two very important terms. So alpha is called the probability of type 1 error. So I can say alpha is the probability of rejecting the null hypothesis when ideally it should be accepted. And beta is the probability of type 2 error. That means beta is the probability of accepting the null hypothesis when ideally it should be rejected. So I hope all students have understood alpha and beta. These are probabilities. So alpha is the probability of committing a type 1 error. That means it's the probability of committing a type 1 error where the type 1 error is rejecting the null hypothesis when it should be accepted. Beta is the probability of making a type 2 error, which means accepting the null hypothesis. Not rejecting means accepting the null hypothesis when ideally it should be rejected because it is false. Alpha is also called the level of significance. We have done this in interval estimation lectures also. Alpha is called the level of significance of the test. And okay, now level of significance means what? Now guys, if you look at alpha, alpha is the probability of conducting type 1 error, right? That means you are rejecting the null hypothesis when ideally it should be accepted. Now, if you reject the null hypothesis, it means your result is significant. Suppose I make a null hypothesis and eventually I am accepting it. It means my result is not significant, not different. Significant means what? Different. But suppose I make a null hypothesis and eventually I reject it. It means I've discovered something different. So that is called significant. So I hope students are getting comfortable with the terminologies and how we are putting it up. Alpha is called the level of significance of the test, and 1 minus beta is called the power of the test. 1 minus beta is called the power of the test. So I hope students have understood this. Now let's understand type 1 and type 2 error using a diagram. So let's analyze this using a diagram now. Okay, so look at the example I'm taking, and then I'm going to illustrate it using a diagrammatic representation. Consider the following test. Consider the following test for a population which is normally distributed. Now suppose guys, we are conducting the following test. All of us know that suppose I make my null hypothesis, suppose my population mean is equal to a particular value mu0. This is my assertion which I have made as a researcher. My null hypothesis is that my population mean mu, which is coming from a normal population, is equal to a particular value mu0. Mu0 is a constant. And my alternate hypothesis is that mu is equal to some other value mu1. Okay, now what will alpha and beta denote? So now alpha will denote the area under the H0 curve, that means the null hypothesis curve, lying outside the acceptance region, and beta will denote the area under the HA curve, that means the alternate hypothesis curve lying within the acceptance region. Now students may not have understood the lines, but once you look at the diagram, it becomes more clear. So you can look at the diagram I'm making. Now guys, we have two hypotheses. One is my null, one is my alternate hypothesis. Mu0 and mu1, both of them are constants. Okay, so you can see I am making two distributions. So you can see that this is my H0 curve. It's normal distribution, so all of you should be familiar with how normal distribution looks like. Okay, you should be familiar with normal distribution, somewhat like this. Okay, this is my H0 curve. That means in this curve is centered at mu equal to mu0, which is my null hypothesis. This is my null hypothesis, right? So my H0 curve is normally distributed with mean equal to mu 0. Now I can draw another curve. This is my HA curve. So how is it going to look like? So guys, I can draw the picture in a more better way. The thing is, drawing in an online lecture becomes a bit nasty, but I'm trying to make it as accurate as I can because it should look like a mesocortic distribution. Okay, so similarly, you can see I'm drawing the HA curve. So guys, this is my HA curve. You can see both of them are symmetric curves. Both of them are symmetric. Okay, and both of them have the same height. The kurtosis is the same. Both of them are moderately peaked. Okay, both of them are coming from normal population. This is mu equal to mu 0. This is mu equal to mu 1. Now guys, look at the definition. So if you look at it, when we were doing confidence intervals, what was alpha? Alpha is called the level of significance, right? So if you all can recall, since it's a, I can say since it's a symmetric distribution, again, let me just make the curve in a better way so that I can properly picturize it for you. Let me make a better diagram. Okay, so this is one diagram I have made. Okay, this is my H0 curve. And look at the next diagram we are making. This is another curve, which is the alternate hypothesis curve. So this is my HA curve. Now the diagrams seem to be fine. Okay, so you can see both the curves on your screen. One is centered at mu equal to mu 0, another is centered at mu equal to mu 1. Now, if you look at the H0 curve, you can see that my level of significance, I can divide it into two parts because it's a two-tailed. You can see it's two-tailed, so you can clearly see as on your screens. This part is also alpha by 2, and this part is also alpha by 2. You can clearly see that what was alpha? Probability of type 1 error. And what was type 1 error? Rejecting the null hypothesis when it should be accepted. Type 1 error was rejecting the null hypothesis when it should be accepted. So guys, look at this area. Look at this area which I am darkening. You are rejecting it because it lies in the rejection region for the H0 curve. Okay, but it should be accepted. Why? Because it is under the H0 curve. So this area and this area are together. You can see alpha by 2 and alpha by 2 together, they make it alpha. Together they make it alpha. So you can clearly see alpha will denote the area under the H0 curve lying outside the acceptance region. Guys, what is my acceptance region? This whole area. This whole area is my acceptance region. This whole area is my acceptance region. And since it's a two-tailed frequency curve, in that case, you can see